All right, everybody. This is 4.1 notes, our new unit on polynomials. We have a lot of vocabulary here, a lot of things that we're reviewing from Algebra 2, with possibly a little bit added, but I believe everything we've done you have done so far. So let's just kind of go through some vocabulary. So vocabulary. Definition of a polynomial is poly means many, and nominal means term. So term is when you have an expression separated by pluses and minuses. Okay, so a monomial is one term. So your examples are like 2x. Okay, so we also have something like, let's do a different color. So we see 5x squared, y squared. Even a number such as maybe -3 is a monomial, okay? That's just a constant. So the second one we have is two terms, a binomial. We're used to looking at these, such as x plus 1, 2x cubed minus y squared, okay? Last one is trinomials, and those are our quadratics that we work with, but it doesn't have to be necessarily quadratic, but that's what you're used to seeing is a quadratic, okay? So something like x squared minus 4x plus 4, but no, again, it doesn't have to be a quadratic, but you can have x to the 4th minus 2x to the 3rd plus 1, something like that. Trinomials, 3 terms. Okay, and note that any polynomial with 4 or more terms is just a polynomial. Doesn't have a special name. Okay. All right, so this next part, what I'll look at is we're going to consider this polynomial, okay? 10x to the 5th minus 9x to the 4th plus 8x cubed plus 7x squared minus 6x plus 5, okay? Okay, so this will be our example here that we'll use when we say consider the polynomial. Okay, so the degree of term is that you add up, so that's the sum, add exponents in that term. So if we look at our example up here, we have terms. So this, and it's in order. So this is term 1, term 2, 3, 4, 5, and 6. So we have 6 terms. So for each one, we're going to determine what the degree is for each term. So for term 1, I'll just put look. Okay, the degree is 5. I'm going to look at the exponent. There's no other exponents to add to it. So term 2 is 4. Term 3 is 3. Term 4 is 2. Term 5 is 1. So let's make sure that you understand that there is a 1 here. Now in this 5, there's no variable there. There's nothing with an exponent. But if you look at 5, 4, 3, 2, 1, the exponents are counting down. So this is in descending order. So really this is x to the 0 power, because remember, anything raised to the 0 power is 1. So that's really 5 times 1 here. So this is a constant. So a special name for those is a constant because they never change. So I want you to think about that term, though, does have a degree. 6, and that's 0. Okay? All constants have a degree of 0. Now, we're going to look at 2 different ways when we talk about the degree of the polynomial, the whole polynomial, not the each term. Okay? So what you're going to do, okay, you're going to look at, the term with highest degree. And that will be your polynomial, degree of your polynomial, okay? So for this example up here, we consider what's up here. If I look at the highest degree for me is this one right here, 5, because all of these, that's 5, 4, 3, 2, 1, 0. So the highest degree is that for that term. So I look at there. So my highest degree for this entire polynomial is 5. Oops. Okay. All right. So now I'm going to do a factored form. So I'm going to put an example here. We don't have one up there, so this is a different example for factored form. So for example, for this one, I have, let's do x squared, x plus 1 cubed times x plus 1. So for this specific example I'm giving you, it's going to be a little bit different, okay? So what you're going to do with these, you're going to add up all the exponents. Hold on, let me erase this so it looks like a 3. Okay? So in factored form, add all exponents. So don't forget there's a 1 here. So I have 2 plus 3 plus 1, so that's 5. So this example is 6. That's the degree of this polynomial right here is 6. Okay, so for leading coefficient, what you need to look at to find that. Remember, a coefficient is the number in front of a variable. So this is a number, okay? So we're going to look at the coefficient for both examples that we have. So coefficient, the leading coefficient is the coefficient of the term with highest degree. So for the example that I have up here, this f of x one up here, our leading coefficient, this is our degree, okay? So the leading coefficient, again, this is a number. Coefficient's always a number. For that example, I'm gonna use, let's just use green. For that example up there, it is 10, okay? Now for my other one over here, this example I'll put over here so you can see it, is what's the coefficient? Well, look at the number right here. Or look at the number, if that x squared wasn't there, look at the number that's in front of it. So it's gonna be just 1, okay? All right. So look at the numbers in front for that leading coefficient. And it doesn't matter that I don't have that all multiplied out on the factored form. It's okay. All right, so here's our end behavior guidelines. So these are literally the end behaviors. Kind of hard on video if you don't get to see my arms, but and when you think of an even degree, okay? So think of, what I want you to do when you do this, think of y squared. Sorry, y equals x squared. I think I said y squared. Okay, so think of y equals x squared. So that's a parabola, okay? So if you think about the end behavior, both ends will go up. So we know that it's going to look like, like this, okay? So both those end behaviors. So I'm looking literally at the end behavior only. So if it's an even degree, okay, ends, and I'll put of graph, maybe that'll help, go in same direction. Okay, so the ends of the graph go in the same direction. So if it's positive, so think about what I just drew. If it's positive, it looks like this. Okay, end behavior goes up, up. So this is like a y equals x squared. I showed that over there. So if it's positive, we know the graph goes up, so that it goes this way. Let me just say up, up. Okay. If it's negative, so think of the graph going down, right? If it's negative, this is like y equals negative x squared. We know it's going down, down, so the end behavior is going down, down. So they're going in the same direction, either up, up, or down, down. So only way. Okay. Now, odd degree, what I want you to think of is either the y equals, if it's an odd degree, or a cubic, okay? So if you're thinking y equals x cubed, okay? All right, so if you think of y equals x cubed, it's a shape of an S, okay? So we want to look at the end behavior. Now, all odd end behaviors do this, okay? If it's positive, it's going to go down, up. So what you notice, even if we go the other way, okay, it's going to go certain ways. So if I'm going to draw it over here, so I know that if I have a positive one, I know if I think of a cubic, it goes in that direction, or even a y equals line, okay? If it's negative, then like the slope will be negative for this one, and it'll go the opposite way. Okay, but notice the end behavior. So they go in opposite directions. Okay, so for end behavior, opposite directions. Now think of always looking at this. So if I look at this positive, it's always going to first down, up, down, that's going down, and that one's going up. So it's going to be down, then up. Just looking in behavior only. For negative, it's up, then down. There's up, and then it goes down. So it's up, then down. Again, if you're here or you're in person, I would be doing my arms so you can see, like, what's the graph doing, okay? All right. So the next thing we want to talk about is the degree. Okay, so the degree determines a lot of things. So the degree, excuse me. So the degree of a polynomial term is the maximum number of turns on a graph and the maximum number of zeros, which we also call x-intercepts on the graph. Okay, now for the maximum number of terms, you're going to take the degree, whatever the degree is, and subtract 1. So degree minus 1. So for our example up there at the top with the 10x, and this degree is always the degree of the polynomial, okay? So for the term was 10x to the 5th, okay? So for here, we look at the 5, we take, that's the degree, so 5 minus 1 equals 4, so this is going to determine how many turns. At the most, I want you to think about this as at the most. We don't have to have 4 turns, but at the most. Same thing with the next one, at the most. The maximum number of zeros, we just look at the degree. So for the example above that we did for the, so it's still 10x equals 5, I'll use this. Since it's a 5, the degree is 5, so at the most zeros we're going to have is just 5. At the most. Okay. Right, next page. So what does a graph of a polynomial look like? So when we're looking at these graphs, I want you to pay attention to what's happening. Okay, these last two are graphs of a polynomial, both of these, but these other ones are not. So if we look at the graph of the polynomial, notice that there's a break here between these two. There's also a hole. Here, if it's not a polynomial, it has like a corner and a cusp. And polynomials that are nice and smooth. These are nice and smooth. There's no breaks, there's no curves. There's no corners. Okay, it's nice and smooth, okay? So what you want to think about is how it works. So what I want you to think about is if you look at your parent functions, the things that have a break, okay, are your rational functions. Okay, and then anything else that has a break, I don't think about top of my head. Rational, even the odd or evenness, I guess I should say both of those. They both have breaks because they don't cross, they have those asymptotes that get in the way. Now for this next one, the absolute graph, because you think about this corner here, the absolute value graph. okay, is the one that we look at it has like corners and such. So those two kind of like tell you they're not polynomials, okay? So just kind of relating it back to what we were doing. So let's talk about what we can do for all this information, and figure out what all this information that we can find out just by looking at the equation. When we do all these, we're eventually going to graph them using that to graph. So first thing I'm going to do is look at the degree, okay? So I look at the highest term. What's always best is that this is in descending order. So if you look, it's a 4, a 3, a 2, and then a 0. Don't forget the 0. So the highest degree there, since I can just see it, is a 4. Okay. Now the leading coefficient. Look in front of here. Leading coefficient is a -1. So I already know that this is an even function with a polynomial and a negative, and it's negative because leading coefficient. Look at the LC. So that helps me think of a lot. So now the degree, though, is going to help us with the max zeros. Max zeros means whatever the degree is. I can have 4. Number of terms I can have is 4 minus 1, which is 3. Take the degree minus 1. Now, if it's an even negative, and I'm thinking about in behavior, they're the same, that means it has to go in the same direction. So this is going to go down, down. Okay, so again, always think of that quadratic. That will help you determine all of them raised to the even power will do the same direction on their end values. All right, let's look at the next one. So the next one I have, again, it's in descending order, which I like. 3, 2, and that's a 1 there, not understood, and then we have a 0. So now we're going to look at the degree. So the degree is a 3, and the leading coefficient in front of here is just a positive 1. So we know it's odd because of the degree, and it's positive. Okay, so that means that helps us determine our end behavior. All right, max zeros, again, is looking just at the degree. Max terms that we can have at the most is 3 minus 1, which is 2. Now our end behavior, if it's positive, it goes in opposite directions, but it always starts down, then up. So you can always think of maybe something like this to help you visualize. That is a cubic, by the way, since it's got a 3. Number 3, is what I want to do is I want to write it in descending order, because if you notice, this is not. You don't have to, but sometimes it helps us to see it better. So I have a -3/4 x to the 3rd. Next is this 1/2 x squared. Again, I'm looking at my variables and their exponents and going descending order. Next is x to the 1st. And the last one's a positive 10. So now when I look at those, I can see that this are my exponents, and then my highest degree is 3. So we have a 3. Okay, the leading coefficient is right here. So this is odd, but it's a negative leading coefficient. So now I'm going to think about going this way. So my max zeros, again, is 3. My max turn is 2. 3 minus 1 is 2. And the end behavior is the opposite of what we saw earlier because it's negative leading coefficient. So that means it's going to go up and then down. All right. I want you to try the next one. I'll pause the video and come back. Okay, so you should have this as your answer. So I wrote it in descending order, 6, 5, 3, and then 1. So I got my degree to be 6. My leading coefficient is 5, just looking at this. Max zeros, I look at the degree, I get 6. Max turns is 6 minus 5. 6 minus 1, I get 5. And then my end behavior, because it's a positive one, is up, up. Okay, so now let's look at this next page. What is true about the function's degree and leading coefficient of the graph? Okay, so we're just going to talk about the degree. We know it goes, the end behavior we know is this way. So this has to be an odd. So the degree has to be an odd because it's going in opposite directions, okay? Now the leading coefficient, though, the way it is positive. That's all we know about it. Is positive, okay? So look at the next one. Again, degree, and then leading coefficient. I'm just write LC because we're in no space. Okay, so if I look at it, it's going down, down, same direction. So this has to be an even degree, but the leading coefficient has to be negative because it's going down, down. The end behavior is down, down. It's like this. So that makes it negative, okay? Okay, so determining end behavior. So like I said earlier, we're going to graph these polynomials. So by determining end behavior and all these certain things will help us to graph our functions. So, I mean, may not know exactly what it looks like totally, but we can sketch a pretty good graph. So, determine end behavior. So the degree and the sign of the leading coefficient, and I'm going to just write LC, and the leading coefficient of a polynomial to determine the end behavior of the polynomial. We've already discussed that, okay? So the second thing we talk about graphing, we're going to look at zeros, determining zeros, and their multiplicity, okay? So when we talk about multiplicity, there's a few things I want you to think about when you look at it, okay? So let's kind of define it, and then we'll get really specific, okay? Multiplicity determines the behavior of the graph at the x-intercepts, okay? All right, it's important. So the number times a 0 or x-intercept, whatever you want to call it, occurs for a particular polynomial is called the multiplicity. So occurs is our word that we need to think about. So for the example, in the equation y equals x plus 1 to the fifth times x minus 1, we have two linear factors. These are linear factors inside here, okay, because they have x to the first power. So for the first one, x plus 1, okay, and the other one is the linear power of x minus 1. And these are linear because of here. This is the first power. The multiplicity, okay, for x plus 1 is 5. I get that from here. The multiplicity of x minus 1, if we put a 1 here, is 1. When you think of multiplicity, look at exponents. That's it. Find the 0 and the exponents. Okay. Now, how that helps us is that if we know the multiplicity, we know what the graph is going to do. So for this function up here, I have a degree of 6. For this right here, we're going to consider that. That's a degree of 6, okay? Add up the exponents. Okay, but the multiplicity tells us by looking at each one. So if it's a degree of 6, we know it's got to go up, or down, down. Right? It has to be opposite direction because it's, and then we need to know the leading coefficients from here, and the leading coefficient is 1. So this is definitely going to go up. But what we want to do is what happens at those values when it's repeating, okay? So even multiplicity, so again, looking at exponents. Look at the exponent, and if it's even, okay, the graph bounces, and you could use the word touch. I like bounces because bounces makes you think, okay, I gotta go back, I gotta bounce and come back, you know. Bouncing usually comes back around, you don't, so if you want to put touch is fine, at that 0. So you have to know the 0. So this would be an example of if it looks like this, if this was an even one, that means it would bounce and go like that. Okay, right there, whatever that 0 is. Okay, now, multiplicity 1, literally the multiplicity of a number 1. So for this, that would be that second one we have, okay? So the graph goes straight through at that. Okay, graph goes straight, and usually I abbreviate ST when I'm doing stuff. Straight through, I'll just put it here, at that 0. So for example, you would have something like this. Going straight through at that one, okay? Straight through. Now odd. I know 1 is odd, but it's other than the number 1. Okay, so pay attention to that. Okay, the graph does a twist. wants to be funny. The graph twists at that 0. So for example, your cubic comes and it bounces, it twists, okay? Let me draw a better graph. So it twists, okay? Makes a twist. So think of a cubic will really help you. So on the next page, what we're going to do is we're going to find these values, find the degree of the polynomial, find the degree and leading coefficient of the polynomial to determine end behavior. Identify solutions of each of the equations below and label as x-intercepts. Determine multiplicity of each factor to complete the graph. You must be in factored form. So I should go up here and stick this up here. Multiplicity must be in factored form because you cannot find the multiplicity unless you are in factored form. Okay, so factor form is not standard form. Standard form is when everything is multiplied out. Okay, so what we're going to do first, we're going to look at degree. So if we look at the degree, we count up all this that we have, and we know we have, this is to the first power, this is the first power. So we have 2, 3, 4. So the degree is 4. The leading coefficient is 0.5. So we know it's a positive, okay? And it's even, excuse me. So that means that end behavior means it has to go up, up. Now, determine the zeros like you always determine zeros. You look at each of these that are up here and you set them equal 0. That's why I'm in factored form. So if you take each one, so 5x squared equals 0, set equals 0, and solve for x. So this is going to be x squared equals 0 divided by 0.5, which is this 0, so x squared is just 0. So I have a 0 here, okay? So I usually write 0, okay? Now what I'm going to do is I'm going to go through, and my next thing I think, now I write m for the multiplicity, okay? So the multiplicity, okay, I have a 0, the multiplicity of, now I look at this exponent of 2, okay? Then I'm going to find my next 0. My next 0 comes from here, so x minus 2 equals 0, so x equals 2. So this next 0 is at 2. But it has a multiplicity of 1. So again, look at the exponent. My next 0 is a x plus 3, so x plus 3 equals 0, so x equals negative 3. So some days you don't have to do this, but especially this one, is that's the one mostly common missed. So there I have a multiplicity of, a 0 of negative 3. My multiplicity is a 1. Again, I got that from up here. And so if I graph that negative 3, my 0 at negative 3, that's here. So you plot those points, and then you determine what this does. So now, depending on how you look at this, you're going to have to pay attention to which way. So if you write this, I've talked to some students, maybe write it in from left to right. So this would be I would rearrange it so that I would have a 0 as my middle one. Sorry. So I have negative 3, multiplicity of 1, then a 0, multiplicity of 2, and then 2, multiplicity of 1. So again, I'm looking at the zeros. So if I look at each one, I'm going to have it, negative 3, I'm going to go straight through. At this one, since it's a 2, I'm going to bounce. And at this one, since it's 1, I'm going to go straight through. So at negative 3, I'm going to go straight through. Well, my end behavior, look, is up, up. So I have to start up here, come down, go through. Now at 0, the next one I'm going to bounce. So I'm going to come down, and I'm going to bounce. It makes nice and curved, okay? Then I'm going to curve here. Now, it doesn't go all the way down, then I have to go straight through because of this next one. Okay, so my zeros are there, and what I did at each. Okay, so make sure it looks bouncing right there. This one goes, the reason I have this side going down farther than this one is because there's more distance between that and 0, between 0, negative 3, and 0, 2. Okay, so let's try the next one. All right, so let's figure out our degree. We have a 2 and a 2, so we know that's a 4. Leading coefficient's a -3. So since it's a negative, the end behavior is going to be down, down, because it's even. Okay, so now when I look at my zeros, I'm just going to look at this. Okay, so if I set -3 equal to 0 for that first one, that is not true, so we don't worry about that one. So my next 0 is a -1, so this is -1, and my other 0 is a sorry, x plus 1. So x minus 1 equals 0, so x equals 1. So I have a 0 at -1 and +1. So my -1, 0 has a multiplicity of 2. My 0 at 1 also has a multiplicity of 2. So each of these are a bounce, right? So I'm bouncing here and bouncing here. But I got to start, but my end behavior is here. So I'm going to go up, I'm going to bounce, touch it, come back through, and come back up. It's really kind of nice symmetrical one because of, think of the quadratic. Okay, number 3, or sorry, letter C. So here I'm going to do the degree. Here's a 5, right here's a 1. So my degree is 6. Leading coefficient is here, +1. Since it's a positive, even, end behavior's up, up. Zeros. So I have a 0 here at -1 and a 0 here at +1. Okay, so let's do the -1 first. So -1 has a multiplicity of a 5, and the other one at 1 has a multiplicity of 1. So plot your zeros, -1, +1. So it's up, up. So if you think about what's happening here, okay, so this is going to come down and this is a twist. And this is straight through. So this 0, so think of twisting like a cubic, go straight down like that, and then come back up and go straight through. So I twisted here. Okay, so the next one we're going to look at is letter D. We're going to look at the degrees. Those are 1 here and a 1 here. So 1, 2, 3, 4, 5. Leading coefficient's a +1. It's odd, so the end behavior has to be down, up. So let's find our zeros. So don't forget this one. Just set it equals 0 if you think you're going to forget it. So we have a 0 at 0, and its multiplicity is 1. My other one I have is a 2 with the multiplicity of 3. And then my last one is a -1 with the multiplicity of a 1. So again, look at the zeros and then their exponents. So let's plot the 2, 0 at 2, and then a 0 at 1, -1. Okay. So -1 goes first. So this was a straight through. Okay, so you're going to go straight through, down, up. And then you go to 0, which is also straight through. And then this last one at 2 is a twist. So I'm going to go 0. I'm going to go, because it's the end behavior is this, I have to start down here. Okay, I go through this. And then at this one, I'm going to twist. Again, if you think of a cubic, you can twist it to where it's a cubic. You can also, sometimes if you, let me erase this part. I have a 0 at 3 or 2. If you know think about the twist, we know it's going to go up this way. We know it's going down this way. It's twisting at this very there. Okay, next one. All right. We have a 1 and a 1 and a 1. Okay, so the degree is 3. Leading coefficient is a -1. So that means it's an odd negative graph. So that means it's going to go the opposite of the other one. So it's going to go up and then down. So my zeros, though, are at -3, -1, and then 2. Okay, so I'm just going to start with the 3, negative 3. So I have a negative 3, multiplicity of 1. Then I have a negative 1 with the multiplicity of 1. And then I have a 2 with the multiplicity of 1. So everything goes straight through. I write just the M for multiplicity because I'm too lazy to write the word multiplicity. If you need to write it a little different to help you, please do so. So if I go over here and I have multiplicity at negative 3, I'm sorry, 0 at negative 3, a 0 at negative 1, and a 0 at 2. I know it has to come up this way. It's going to go straight through, and then straight through. All right, next one. I see that I have a degree here, a degree of 1, 2, 3. My leading coefficient is a positive 1, it's right here. And my end behavior is down, up. Okay, so I have a 0 at x equals 0, and that multiplicity is 1. And then I have a 0 at x equals 3, and that multiplicity is a 2. So this is going to go through, straight through, and this one will twist. So I plot my zeros at 0 and 2. And I know that I have to go start down. So I'm going to go straight through here, come here, bounce on here, and then go up. Oh, sorry, I wrote twist. I apologize. It's not a twist. It's a bounce. All right, so you should be able to do end behavior and all those to determine what the graph sort of looks like. We don't have all the points in between the zeros, but we have a good sketch. Okay, for this last one, what I want you to think about is see what you know about end behavior to match the polynomial function for this graph. So if I look at each end behavior, so let's just look at each one of those. So this end behavior is down, up. So this is a odd degree, has an odd degree, but it's also positive. Okay, so the leading coefficient has to be positive here. So this is a negative, excuse me, it's even because it goes down, down, but it's a negative leading coefficient. Up, up here, so it's even again, but this time it's a positive LC. Let's put LCM there. Last one is up, down, so it's odd, and it's a negative LC. Let me write this a little better. So now, just based on that, be able to find what each one belongs to. Well, this one right here, it's in descending order, so always check. They're all in descending order. This is the degree of 6. This is even, even. Okay, so I'll just look at the even ones. Here's even, even. So this first one's an even positive, so this is letter B. And this one is an even negative, so it's going to be C. Then when I look at the other ones, this is odd, okay? And here we have another odd. Okay, so this first one is odd negative, so my odd negative is letter D. And this one's an odd positive, so this would be letter A. So again, you don't even have to know what the graph looks like. You just have to, you just look at the end behavior to help you look at the graph.